Chapter 5, Section 5 is about using the law of sines. When using the law of sines, you might solve for a side or an angle. In 5.5a, we focused on solving for a side. Remember, when we solve for a side, we are safe using the law of sines. In other words, we will not need to check for a second triangle. But if we use the law of sines to solve for an angle, danger, we will need to check for a second triangle. Example 1. We will use the law of sines because we are given a side and its corresponding angle. Using the law of sines to find angle A, we will set up a fraction with the sine of the known angle over the known corresponding side. Since we know angle C and side C, that is sine of 50 degrees over 1. We're going to find angle A because we know side A. We set this equal to the sine of angle A over side A. To get the sine of A alone, we will cross multiply and divide. Sine of A is 2 multiplied by the sine of 50 degrees all over 1. Next, we want to get angle A alone. What is preventing angle A from being by itself is the application of sine. To get rid of sine, we need to apply inverse sine. What we do to one side, we do to the other. By applying inverse sine to sine of A, we get A, and using our calculator in degree mode, the inverse sine of 1.532088886, we get an error. Why would this happen? Any number larger than 1 is not in the domain of inverse sine. What this really means is that we cannot build a triangle with this given information. So the answer to solve the triangle is there is no triangle that can be built. Example 2. We will use the law of sines because we have a side and a corresponding angle. Side 3 and corresponding angle 40 degrees. Using the law of sines, we will find angle B, setting the sine of 40 degrees over 3, because 40 degrees and 3 are corresponding, equal to the sine of angle B over side B. We can get sine of angle B alone by cross-multiplying and dividing. So the sine of angle B is 2 multiplied by the sine of 40 degrees divided by 3. Using your calculator in degree mode, we can find the decimal approximation to 2 multiplied by the sine of 40 degrees divided by 3. We still need to get angle B alone. Angle B is not alone because sine is being applied to angle B. To get rid of sine, we will apply inverse sine to both sides. The inverse sine of sine B is B, and the inverse sine of 0.428525073 is this. You want to use as many place values as your calculator gives you so that your answers are as accurate as possible. It is fine to round final answers, but remember, if you are going to reuse a value, you want to keep as many place values as possible. With the given information, we just found an angle using the law of sines. danger. In other words, we are going to need to check for a second triangle. It is possible with the given information that more than one triangle can be created. If you remember back to geometry where you had properties like side, side angle, side, and so forth, this would not have been a property. The easiest way to think of this is if the given information contains a side and its corresponding angle, and you immediately solve for an angle using the law of sines, you need to check for a second triangle. The second triangle, if there is one, would be named triangle A prime, B prime, C prime. We begin as if there is a second triangle. To find angle B prime, we subtract the angle measure we found using the law of sines from 180 degrees, because these two angles are supplements. After we subtract, B prime is 154.626061 degrees. Now we will make the decision if there is actually a second triangle. We want to take the given angle and add it to the possible B prime. If we add these two angles together, we get an amount that is greater than or equal to 180 degrees. That's impossible. Simply put, if you add the given angle to the B prime angle and your value is greater than or equal to 180 degrees, you know there is no second triangle. The reason this is true is because when you add up the three angles in any triangle, it's going to equal 180 degrees. Just using angle A and B prime, we are already over 180 degrees. Now that we know there is no second triangle, we just continue on with the information we found so far. We just found angle B, so all we have left to find is angle C and side C. We cannot find side C until we find angle C. Using the fact that all triangles add up to 180 degrees, I substitute the two angles I know, subtract them from 180, and find angle C. Now that we have angle C, we will find side C. The sine of 40 degrees over its corresponding side 3 equals the sine of angle C over side C. We can solve for C by cross-multiplying and dividing. Using our calculator in degree mode, we find that C is approximately 4.243.